right, everyone. Hello, everyone, and thank you for coming here at such a busy event. It's been pretty fascinating. It's probably one of the best data AI summit I've attended over the last few years. It's the biggest one, obviously. So today I want to spend about 30 minutes or so over how you can build AI systems or apply AI to your data, and in a way that is fast, cheap, and automated. And before we go into it, I want to start with kind of what's happening underneath all this amazing revolution that we are part of. This is a graph of Moore's law, 125 years of Moore's law. And on one axis, you see how much compute one could buy at a constant dollar. So if you adjust the inflation, and et cetera, you kind of like see this trend. And what's really interesting is that in Intel chips kind of like stopped leading that kind of trend, and NVIDIA GPUs, ASICs, and analog ASICs are actually leading the way over the last 5-6 years. But also what's really fascinating is that this is an exponential trend, and the steepness of exponential trend is actually even higher in the recent years. And in perspective, over 125 years, same dollar buys you billionth X compute, and there are no signs of stopping. Like, it's just getting started in many ways. Every year every couple of months we're seeing breakthroughs that are driving this trend, where a dollar will give you more compute than ever. Now, this also means that the progress that we are making, so the progress we make in AI and computation in the next 5 years is going to be much more wholesome, or much more bigger than the progress we made over the last 10 years or 20 years, right? Because it's an exponential trend. So the progress in next 10 years is going to be bigger than the last 50 years. And that is really fascinating times to be living in. As Elon says, this is the most interesting of interesting times to be living in. Now, in this backdrop, we saw one of the significant points in AI journey, which is in 2022, we saw emergence of foundation models, which is in many ways have changed nearly everything in the last 6-9 months, really. And this became much more apparent with ChatGPT moment, which was, I think, in November or December. But before that, there were a number of foundation models being developed out there, and people were tinkering with them. Now, the fundamental thing that is different about this is as follows. Before foundation models, the way you built AI systems required lots of human-labeled data. You would collect the data, you'll have humans label them, you'll train these models, test and evaluate them, and then ship it to production if it met certain benchmarks. But foundation models are fundamentally different in a sense that they are trained on internet-scale data, just your corpus of information, whether it's text, images, video, or some sort of a combination of these things. And they're trained to baseline models, and then, of course, they're adapted to your enterprise use cases, whatever it may be. And to go one level deeper, the data is created. So in the enterprise context, you have a huge corpus of information stored in Delta tables or other data warehouses. And the data needs to be converted to a data set, deduplication and selection of information that is going to be useful for a GPT-like system to learn. And then, as we all learned today morning, model training with things like Mosaic ML is becoming easier and easier. And at the end of the day, you get a model, a foundation model that can have really powerful capabilities. Now, key thing here is that this is all a computational process. There is actually no humans involved all the way until you get a baseline model. And I think we are in the very first innings of what these systems are going to be able to do because of the Moore's law that we saw earlier. Again, these systems are getting better at faster rate than a lot of the CPU chips were getting better, like in the last decades. And that foundation models, the fundamental things that drive foundation models is computational process. It is very fair to assume that the models that you have access to today are going to be very obsolete very quickly. And the models you're going to train next year or a year after next are going to have profound capabilities that are possibly hard to imagine today. Now, the way I personally kind of visualize this in my mind, like what is this, like how to kind of comprehend this amazing technological trend is as follows. Like if you just sort of thought of these AI tasks to be sort of like buildings and homes and, you know, is terrainous in a very kind of diverse terrain, and there's some sort of like a water level, which is basically base intelligence. And the base intelligence is rising every second, every day. And the kind of tasks that we thought once were impossible are basically available to everybody. And that's a democratization of AI that we are experiencing today. Like just a few years ago, a number of our enterprise customers would have a dedicated AI team to do OCR or to do sentiment analysis or to detect certain common objects in their visual data. And now it is widely available as a common intelligence capability among these foundation models, such as GPT-4, Meta's Segment AI, Segment Anything. And there are the tasks that are really at the top, which are still up for grabs, meaning that these tasks that you see at the top are really all about the nuanced understanding about businesses, the data that you have access to, the nuanced insights on how you want to interpret that data to improve your products and services. And those kind of tasks are still out there that we all are trying to make it easy for us to develop these capabilities. And but overall, it's really fascinating to see like how fast the AI is moving, and of course, the kind of things that are possible. Now, with all of these tasks that are certainly available with foundation models, it has led to kind of a new opportunity within enterprise. Over the last few years, all of our customers, and all of you guys are probably were building lots of AI systems yourself, and that continues to be the tip of the spear for all of the efforts. Like if we could make custom AI models for our products and services and build this data flywheel, that's obviously the perfect situation. We have learned this over and over again. A great example is Tesla's autopilot system. These cars are on the road are growing very fast. They generate data. Tesla's AI team is able to take that data and build, prioritize those data sets and improve model and ship a better model to the cars. Now, with this sea level of intelligence, artificial intelligence rising, and certainly all these tasks are available, we are seeing 10x more use cases within the enterprise that were basically depriced, but basically like no one was working on. Like there was no ways to unlock ROI with these kind of use cases. What are these things? Like document processing, summarization, information extraction, classification of your data, enrichment of your data sets, and all of these tasks are making basic workflows in the enterprise super fast, better, and cheaper. In some cases, we are seeing companies just invent new ways to work by simply applying these amazing model capabilities onto the data. Now, the challenge is that all of these capabilities, whether you're building custom AI models or whether you are simply applying AI onto your data, turns out that these AI models are basically one of the three categories. Task-specific models, these are CNNs. Obviously, like lots of models that are out there in production. They are essentially, convolutional neural networks or transformer architectures. And the reason we are building task-specific models is to meet certain constraints, whether it needs to be on the edge, whether it needs to have some sort of latency requirements. Sometimes, like deploying model for information extraction is much cheaper than to actually, like, say, use GPT-4 at high volumes. And then we have a new emergent capability, which is purely from foundation models, where you're using prompt engineering and retrieval augmentation to support new applications was an example of that. Q&A on your data is a perfect example of it, where you don't need to train any model. You simply need to create an end-to-end system. Or the last one, which is fine-tuned foundation model. So you actually go train a custom model from the corpus and then fine-tune it with RLHF or instruct style labels. Now the challenge is that all of these models that are now available and that basically 80–90% of use cases are one of these kind of models, we think that they're accelerated. We are seeing that they're going to be accelerated by foundation models, but also all of these models require a lot of work still. 80% of the task to getting these models to production or to be more useful to solve business use cases requires these data-centric jobs, whether it's search and exploration of data sets, pre-processing, sometimes pre-labeling or enrichment. Data labeling, of course, is required, especially if you want to align LLMs to your use cases. Or whether it's like data workflow, an end-to-end workflow that is operating across your real-time data streams and number of models operating in the sequence. And turns out that the neural network-centric work, which is actually inferencing, training, it turned out to be much simpler. It's super easy to do that now, especially in Databricks environment. You just press a button and it just does that thing for you. And so data-centric job continues to dominate the amount of investment, the time that we spend to making any of these models work. This is where Labelbox over the last few years have made AI development, we have taken all the biggest challenges with data-centric jobs and made it super simple for you all to build these AI systems. And the way we have approached this problem is, well, every single team requires a way to search, explore, and curate their data, whether it's computer vision data sets, whether it's text data sets. We have brought traditional and vector search together onto these data sets, so you can select precisely the data that you need to move it to the next step. Then we have capabilities to pre-label that data sets with your models, and of course, if you optionally need to label that data with humans, you can do so with our system, and of course, then proceed to model training and optimization through error analysis. All of this is in a simple, intuitive workflow on Labelbox platform. And we've designed the product in a way that it's flexible to use. Some companies like Warner Brothers, who are simply enriching their data sets, are using our catalog product and applying models to it to make predictions. But some companies like John Deere are using our entirety of our platform and products to make use of the data and opportunity with the AI systems. Now, our customers over the last 9 months are asking a lot of questions, and they typically end up like being one of these things. How do we make it faster to experiment, test, and select generative AI models? A lot of our companies, a lot of our customers were primarily building task-specific models over the last few years. And so, of course, when the advent of GPT-4 and tons of foundation models, that's the top of the mind question. How do we build solutions with Gen AI models? Well, they are these amazing models, but like, well, I have an actual business use case that I want to solve, and it requires a workflow, end-to-end workflow, for me to actually ship a application. And so how do I do that? How do I automate labeling? And I think I've never met a single company or single customer where they're excited about spending a lot of money on labeling. And so everyone is excited about like, how do we automate that? Could we even reduce the human labeling or eliminate it altogether? And perhaps what's an appropriate AI system architecture for my task? I remember I shared 3 different categories of AI tasks, and which one should I use? Should I be actually training my custom GPT model and fine-tuning it? Or could I actually get away with in-context learning-based system or a task-specific model? And to answer all of these questions, we are super excited to be announcing Model Foundry. Model Foundry is a place for you all to play with and experiment and choose any of the amazing hundreds of foundation models that are out there. So think of Anthropic, OpenAI, all the models from Databricks, tons of open source models. With Foundry, you can actually use these models, apply to that on your data, and essentially do the tasks that I mentioned earlier: summarization, information extraction, data classification, and so forth. Now, today, if you go onto Labelbox, you will see you can sign up for Foundry, and it's super simple place for you to actually explore all of these amazing models that are out there and what their capabilities are, and more importantly, how to actually use them on your data set. What's an example of that? Well, in natural language, we have customers who are who have, like, in e-commerce sector, there's lots of information about listing. Like if I have a product that I'm putting online, there is description about the listing, there is perhaps a bunch of photos about that listing, and companies typically need to categorize these listings in the right ontology, like the appropriate ontology that they maintain. And typically they would have lots of humans actually do that task until now. And with Model Foundry, they're able to actually just employ a GPT-4 or ChatGPT-like system and pass all of that information to it to do the task for them. And of course, these GPT systems can make mistakes, like they hallucinate, and so humans are still in the loop. We learned today earlier where Satya and Ali talked about human in the loop, or retrieval augmentation systems are basically the two means to ground these foundation model systems. So Labelbox offers an end-to-end solution where you pick a foundation model, apply that on your data, and perhaps do a random sampling and give it to a human in the loop system to maintain quality. So here's an example. The same use case that I mentioned, but in this case, I've brought all my data from a Delta table in Databricks, and I want to do an information extraction job, which is a very common task we see in healthcare, insurance, and because we already know the ontology that you care about, we can automatically generate a prompt for you and give you a very quick way for you to experiment GPT-4 or Cohere or Anthropic or any other amazing models that are coming online to perform that task for you. In our experiments, we have seen this to be about 88% faster than any other means that is out there. And at scale, when you have millions of these data points coming in, whether it's existing in your Delta tables or whether it's streaming in, that's a very big cost savings, and it's super fast to do that, of course. Similarly, Foundry works on other modalities. So here's an example of computer vision. And so again, remember, like I mentioned earlier, where there were certain tasks where there would be machine learning teams building task-specific models to detect a lot of objects in images. And they would have like millions of dollars of budget to label the data, train these models, et cetera. But now, with foundation models, it is a lot of these tasks are available and can be done right away. And so again, in Foundry, so if I wanted to detect a whole bunch of like attributes, again, this is an example for retailer, a company like Nike or Adidas who have like lots of portfolio, they want to extract like clothing or attributes and perhaps change the backgrounds or find more interesting, curate more interesting catalogs for different purposes. In Model Foundry, you can use segment anything or a YOLO or combination of these models to automatically enrich these data sets that once would require massive amount of investment to do. And so you automatically label that, enrich that, and of course have human in the loop system to do Q&A. Again, incredible results, 88, 90% cost reduction than any other means that we are aware of. Now, in addition to that, one of the biggest challenges we see with large language models is there are just so many of them, and how do I choose the best large language model for my task? And we are excited to also introduce capabilities in our Model Foundry and Model Product where you can use GPT-4, you can basically select GPT-4 or a PaLM model or Anthropic and basically do A/B testing and see which one actually works best for you. And typically that is actually the first thing that teams are doing now, where they want to basically start with selecting the right base model before they go on to building a retrieval augmentation system or in-context learning AI system. And it's super easy to do that. You simply bring in the prompts and you summon one of these models, generate responses from all of these different models, and in a single view understand which ones is the best performing for your task. Now, in addition to that, today, as we saw, like Databricks, it's going to be super easy for all of you to train LLMs or to fine-tune LLMs. And whether you are bringing an existing LLM as a base model for in-context learning like systems, or whether you're fine-tuning it, the challenge is that these LLMs needs to be adapted to your use cases. But also, these LLMs need to be evaluated to ensure that they are actually preferred by your target audience. And so we are super excited to also introduce new capabilities to our annotated model product, where you'll be able to use our Labelbox to generate data for reinforcement learning from human feedback, instruct GPT-like data sets, but also, very importantly, evaluate LLMs. And I'll tell you like how our approach is so different than anything else that you see out there when it comes to evaluation of LLMs. So first thing first, when you are fine-tuning LLMs, you need to generate human preferences. And it is very known at this point that most of these LLMs are already have a very good baseline capability about reasoning and understanding about the world matters. And that is, and we see that it outperforms most of the crowd out there. So, so generally, these LLMs have very good kind of intelligence. And the challenge is that, well, if you want to start with that and adapt to your enterprise use case, you still need to align these models with your own kind of like use case. And it typically is done through subject matter expert. What's an example of that? Well, if you're a healthcare company and you want to cater to your audience, such as patients, maybe it's a clinic or certain kinds of narrow domains, the LLM needs to be able to kind of understand or mimic the style that you want, or the kind of concepts you want it to talk about, or in certain tones it needs to exhibit to provide better experience to your audience. Well, you'll need to generate human preference data on how you want that LLM to behave. And so with our annotated product, it's super easy to generate these instruct GPT or RLHF-like data sets, whether it's with your domain experts teams or whether it's specialized teams that you can that we have network of around the world. Now, when it comes to evaluation, we are working with OpenAI and Cohere and a number of other companies. What we've learned is that fundamentally, LLM evaluation is a very human-centric process. And the reason is as follows. LLMs are increasingly becoming very competent. And there are automated evals that we all use to kind of like pass the basic test during the development. But ultimately, you have to prove that your LLM that you're going to ship to production is actually preferred by your core audience. Is it actually helping your users that is buying your products from e-commerce increase their sales? Is it actually reducing customer kind of complaints or escalations? Well, the best way to do that is you have a couple of models that you are working with. So you version 1, version 2, and you essentially ask a group of people to rank and to select the best model that is preferred by them. And that is how LLMs are evaluated before they go into production across some of these biggest LLM providers that we are seeing in the private context. So our product Annotate is going to make it super simple for you to generate and to rank and to select the best model before you go ship it. And in many ways, think of it as a test that is always running behind the scene as your LLMs are being developed. Anytime you change a parameter, anytime you change a prompt in LLM, in context learning systems, or if you fine-tune it and you change some sort of hybrid parameters, you kind of have to figure out a way to make sure that the new LLM version is better and actually preferred by your core audience. And so this is going to be the way for you to very easily get that litmus test and answer for that. Lastly, we are also super excited about introducing a new way for you to build kind of applications, end-to-end applications using foundation models, also leveraging kind of like lots of the integrations that that we have built recently with Databricks and others. Well, one of the challenges that we see with AI development and application development is as follows. Like there are lots of discrete steps teams have to go take. I have to bring my data from BigQuery or Databricks Delta Table into kind of like a platform to curate the data sets. Maybe I need to actually use a ChatGPT model to automatically generate inferences or like metadata. But perhaps after that, I need some sort of a human-in-the-loop process to ensure that the responses generated by GPT-like systems are actually quite great or are high quality. And so we, with pipelines, we want to make it super simple. So think of any business use case that you're working on with, and you either you're building a custom AI model yourself, or you want to simply apply AI to your data to solving that business use case. You can map it out in our pipelines product, and whether it's a batch processing or real time, we will take care of all of the orchestration of these workloads, including inferencing or batching data to different states. Similarly, similarly, it works across all of the kind of modalities. So whether it's computer vision use cases or NLP, pipelines kind of makes it super simple for you to set it and forget these kind of pipelines. You will also have access to full observability, so understanding like how many inferences were done, what was the quality of that, perhaps going into a human-in-the-loop system and understanding like what the parameters being used and what the quality of human judgments are being you have full observability into every single discrete process that is going on inside our platform. Now, of course, a lot of our users are building writing a ton of code to making this kind of simple. Whether you're using the notebooks in Databricks or whether you have data science data teams or software teams helping you build these systems, end-to-end systems, we think that ultimately less code is better. And with using Databricks Delta Tables, Databricks workflows, and Labelbox pipelines, you'd be able to kind of, with minimal code, achieve incredible AI breakthroughs. And no matter what kind of use case you have with computer vision or NLP, with pipelines, you're able to achieve that outcome end-to-end. So with that, I hope you kind of got a glimpse of how Labelbox can actually help you build incredible applications with AI, whether it's custom AI development, which we have been incredibly successful over the last few years, or whether it's applying these amazing AI models onto your data to solving use cases that once were nearly impossible. And our platform simplifies that, simply bring the data in, pre-label and enrich it, now with all of these amazing foundation models. Optionally, have human-in-the-loop system for grounding, and then train or deploy those models into production. We sit on top of all of your data lakes and cloud infrastructure. So we have native integrations with data lakes, storage, compute providers, of course. And in addition to that, we have brought on hundreds of these amazing foundation models onto the platform. We are literally the only place on the internet that you'll have access to all of these amazing foundation models and apply that onto your data. So that's it. Check out labelbox.com and sign up for the product, or reach out or come to our booths downstairs. We're right next to Databricks, and yeah, I'll take some questions.